Hello guys, so for this integral, what do I want to do? I want to evaluate this integral by using integration by parts, but I'm going to use a different approach compared to my previous video. So here I'm going to apply column method, or in other words, DI method. So idea of that approach is the following. First, we again need to choose what is our u and what is our dv. And in this case, like we have that u is 1 minus x squared and dv is e to the power of 2x. And then I'm going to write like those two columns, where my first column, I'm going to take the derivative of my u, and my second column, I'm going to take the integral of my dv. And you can see the derivative of u is going to be negative 2x and negative 2 and 0, and integrals of dv are 1/2 e to the power of 2x, and etc. And we're going to stop when so for how long we're doing that. We're doing that until our u is going to reach 0. And to check that we have the following answer for our integration of exponent, what you need to do, you need to take your final answer, which is 1/2 e to the 2x plus c, and just differentiate, as integration and differentiation are opposite operation to each other. And then you can see that we're going to get the same function e to the 2x. And then approach is the following. You take the first element from the first column and second element from the second column, multiply them, then take the second and third corresponding element, also multiply them, and then when we're going to add those elements together, the first element, first product, is going to go with positive sign, but our second product, here's attention, is going to go with a negative sign. And again, our third product is going to go with a positive sign. So you can see idea of the column method, that we're going to just write our function into columns. Then we're going to multiply them together, and we're going to add them when we're going to switch our signs from positive to negative, and etc. So in other words, we're going to get this answer as a function. But let's right now evaluate that answer by plugging in. Oh, by the way, I did a mistake, so my boundary points between 1 and 2 and not 1 and 3. So to finally, to find the final answer, I just need to plug in my 2 and 1 inside my functions. And you can see I did some computations over here before I recorded this video, just to make sure that I'm going to get the correct answer. And that's why we're going to obtain the following final answer. So for our second problem, we can use different approaches, integration by parts, but actually you can solve this integral by using u sub. So we can first observe that we don't like the bottom part, and we know how to find the integral of 1 over square root of x. So let's actually make a new variable u, which is 3 plus x squared, and then you can see that my du is going to be 2x dx. And then remember, when we're changing the variables, we also need to change the boundary points. So that's why u of 0 is going to be equal to 3, and u at 1 is going to be equal to 4. Then after that, you can see that we can rewrite x to the power 3 as x squared times x, where x times dx is going to be equal 1/2 du, and our x squared is going to be just u minus 3, as we can just move 3 to the left-hand side in our substitution. And finally, we're going to rewrite our integral as integral from 3 to 4 of u minus 3 times 1/2 du over square root of u. And then since 1 over square root of u is going to be just 1 over 1 u to the power of 1/2, so I'm going to obtain, I'm going to move my constant 1/2 to the front, and then we'll have integral between 3 and 4 of u minus 3 times u to the power of negative 1/2, and then I can just bring my negative 1/2 inside, and after I'm going to integrate, I'm going to obtain the following function with the boundary points 3 and 4. So let's actually compute and find the number, as a final answer, as a number. And for that, I'm going to plug in my just 4 and 3 inside my function, and then you can see that I can move my 2 to the top. Again, I'm going to discuss this later, that if we have double fractions, then you can just bring bottom parts of fraction on the bottom to the top. And basically the idea is that we're going to obtain the following final answer, which is 11 over 3 plus 2 square root of 3. And you can check your computations by just following my computations, or first do your computations and just check that you're going to get the same final answer. So for this problem, it's like a word problem. We know that r at 0 is 0, that our x between 0 and 2, that we have two functions, that area under that function when x changes between 0 and 2, for the first one is equal to 5, and for the second one is going to be equal to 10. And for our goal, what do we want to do? We want to just find what is R2 times S2. So first, let's just observe that if we have S times r prime, then I'm going to have s prime times r plus r prime times s. And then observe that ds over dx is the same as s prime, and dr over dx also r prime. So that's why I'm going to have function k of x plus h of x. And if I'm going to take integral of both sides, then I'm going to obtain that integral between 0 and 2 of s of x r of x prime is the same as the function evaluated at 2 points, 2 and 0. And then I'm going to have the sum of two integrals on the right hand side, and as geometric definition of the integral is the area under the curve, that's why I know that the first integral is going to be equal to 10 and the second integral is going to be equal to 5. And then if I'm going to rewrite my sum on the left hand side and s r of 0 is 0, then I'm going to obtain that s2 times r2 minus 0 is equal to 10 plus 5, which is 15. So that's why my final answer for this problem is going to be 15.